Alright, we're going to get started here in just a minute. Can everyone hear me okay? Somebody in the live chat say something about sound levels from the mic. How about now? My monitor volume sounded awful loud when I was tuning this, so I knocked it down real low. Oh, that sounds way better. Okay, I'm going to go ahead and get started. I am going to keep an eye on the live chat window, so if anyone has any questions, feel free to raise your hand and say something. There's about a 5 or 6 second delay, so if I don't get right to you, that's why. And I'm going to pull the monitor out because that's driving me insane. So what we're going to do tonight is we're going to model this fork, this beautiful purple fairy fork that is going to be repurposed for my drift trike and a 20-inch bike wheel to go with it. So we're going to cover some basic modeling techniques, extrusion, revolve, and sweeps. And I'm going to show you guys how to model off of standard planes and some basic navigation stuff in Fusion 360. So to get started here, let's get oriented with this model space. So this is the fork that we're going to model. This is a little bit like a cooking show. I've already modeled this once, so I've got a pretty solid idea of where I'm going with this. So this shows our model in our workspace. Down here is one of the really neat features of Fusion 360. This is called the timeline, and it's a really unique feature for a 3D modeler. Basically what it does is it lets you see how the model was created in time and also go back and edit the model in time. And as you're learning, this is a really powerful feature if you have access to an existing Fusion project, because if you notice, it looks kind of like a video player right here, and if you hit play, we can go back in time and kind of see how I created this model. And that's really useful as you're starting out. So that's pretty cool. The next thing that we should look at is what's called the model tree. And the model tree is very important because it contains numerous parts of our model that matter. So at the very top, at the root of the model tree, this is the root level component. And Fusion 360 has 3 different levels of parts that exist in the model tree. It has bodies, which are contained in this folder here. And bodies are kind of dumb lump geometry. They don't have anything really associated with them. We can edit them, but they're really just kind of like a chunk of modeling clay. That's all they are, is a 3D body. They have nothing else associated with them. And inside, associated to the body, is a component. And the component contains all of our model data. So it contains a model origin, which is this coordinate system that we see down here in the middle of the fork. It contains our bodies folder, so any bodies that pertain to our model. So if I had, if this was broken into separate pieces, I would have multiple bodies in this folder. The sketches that I used to create this component are all contained in it. And then the construction folder contains all of the different construction geometry that I used to create this model. So it contains our datum axes, datum planes, and any reference points that we use to create our model. So that's all super useful. And then the next level up is called a component group. And a component group is just like it sounds. It's a group of components. And in other CAD softwares, this would be called an assembly file. So as I start to assemble multiple parts together, like I did here, I'll give this a second to open up. So you can see here, it's got a rectangular block and then a little square block. That means it's a component group. And that component group contains both my wheel and my fork. And this wheel is a good example because it contains two different bodies, this axle and then the tire body. That's kind of a high-level overview of the file structure of Fusion, and later I want to make another video to really kind of drill that stuff down. But it's very important to understand that stuff early so that the models you make at the beginning are as good as the models you're going to make in 3 or 4 months. So let's go ahead and get started. Does anyone have any questions with this right now? Give that a second while I create a new design. So when we create a new design, first thing that we want to do is give that design a name. So we're going to save it, and I'm going to say Fusion class fork. Tim asked if I'm leaving the data panel open on purpose, and sort of, mostly because I wanted to show how these things are created. So the data panel is an important differentiator between Fusion and local-based CAD software. So Fusion is all cloud-based. So as I create files, it will create the files in the data folder here, and it will make a cached file on my computer that lasts for about 2 weeks. But in reality, all of my CAD data lives on Autodesk's cloud. So if you're afraid of cloud software, Fusion might not be the best thing for you. But so we get some more screen real estate, I am going to close this down. So the first thing that Darren asked, how do I turn on the timeline view? So timeline, as you can see down here, is turned on by default when you create a new Fusion file. When you import geometry that was not created by Fusion, so if you imported a DXF or an STL or anything like that, you have to actually right-click on the root of the tree, and instead of do not capture design history, it will say capture design history. And the difference is when you work on a file that was not created in Fusion, it defaults to a modeling theory called direct modeling, so that we can act on bodies that were created before, but it won't by default capture that history because it doesn't have any history to begin with. As soon as you turn that on, it will create what's called a base feature, and it looks like a dumb lump down in the timeline view. And that is not editable before the base feature was created, but as you act on it, it will add things into the timeline like sketches and extrudes and stuff like that. I hope that made sense. I can demonstrate that in a later video. Okay. So I saved my file, I gave it a name, and the first thing that I notice when I look at this fork is there's nothing on this fork that's rectangular, right? It's a bike fork. It goes and then it's got these dropouts down here to hold the wheel. So what I'm going to do to create this fork is I'm going to do a loft for the legs and an extrude for the head tube. And I think that trying to come up with this mating area right here out of nowhere is going to be fairly difficult. So what I'm going to do is I'm actually going to start by lofting one of the legs. So to do that, I'm going to use 12-inch calipers. These are my favorite tool for reverse engineering things that I don't need to be perfect in the model. I just need to be pretty good. And that's exactly what this model is it needs to be pretty good. So what I'm going to do is close my jaws up, check that they're 0, 0-ish, and I'm going to measure from the bottom here and look for where the bend kind of starts. And I'm also going to give it a whole number because making assumptions here that the engineers that created these forks weren't sadists and worked off of whole numbers in the metric system, because I'm sure this fork was made in China. So the straight portion of the fork is 200 millimeters. So I'm going to create a new sketch from the bar up here, and I've added a lot of buttons to my tree. So if you don't have the create a sketch button, drop down, create sketch, and then pick what plane you want to use it on. So this is the y-axis, the green line, x-axis is red, z-axis is blue. I like working on the x and y-axis for most things just because it feels right. And to create this, I'm going to say line. And when I create my first point, I want to create it with purpose. So I want to work from my coordinate system, and because this fork is symmetric about an axis down the middle, I'm going to say that the origin is here-ish in the middle. So I'm going to come over a distance and click to start my line and go up and tell it that I want to go up 200 millimeters. Now, if I measure between the legs of my fork, again, eyeballing things and making assumptions. I'm sure I'm making a lot of people mad by doing that, but I don't care because they're not here. I'm going to say that it's about 120 millimeters from center to center on the fork. So I need to make a sketch dimension to tell Fusion that's how far that line should be. So again, sketch menu, sketch dimension, or you'll notice there's a lot of letters in these menus as you go through them. You can just click D and D will give you a sketch dimension. Go down, and it's 60 from the center. And then the next step is if I take my calipers and I make a scratch in my beautiful paint. These are going to be painted lime green in their final life, so I don't really care what this awful purple fairy paint looks like. I'm going to eyeball the center line here from the top of my 200 millimeter line. It looks like it's about 95 millimeters to the center of the pipe right here in this intersection. And that's a really nice arc. So the way I'm going to create that arc is with a 3-point arc. And I'm going to go up from here and just click, and then click at the node here. And as I move through it, you'll see that there's a snap. And that snap looks like a circle with a line on top of it, and it's at this node right here. And that means it's a tangent arc, so that the arc is tangent to the straight line that I'm creating. And that's really important because that is how you get these nice archy lines here. And this model is purely for reference, so I don't really care if that's really a tangent arc, but what I do care about is how far this point is from this point. So when I create a sketch dimension, I used the D key to start it. If I drag it by default, it makes an aligned dimension. So that means it's aligned at an angle, and that's not really what I want because I don't care what that is. What I do care about is vertically. So as I move my cursor, it changes, and then I can go up and it changes how all that is. So I want this to be 95. And it did something that I didn't like. It moved, when I made this 95, I constrained this arc, but what wasn't constrained was the fact that this point was aligned to my origin before, and now it's not. And I care about that because I wanted that point to be there. And the way we fix that is with constraints. So what I'm going to do is I'm going to use the L key on my keyboard to create a line. Go from here and intersect it with that line. And then hit escape to cancel that command. And then I'm going to go over to here to my sketch palette, which my window is covering up, my sketch palette, and click coincident. And coincident makes points and lines stick to each other. It's a really good, it's the best way I've got of putting it. So I'm going to click on this line here and this point here. That sort of did what I want. Let's give it one more constraint, the horizontal vertical constraint, and tell it that that line should be horizontal. That put it almost back. We'll do one more line, vertical, all the way up. Click that little check box there. Get the coincident constraint again. Click on this endpoint, click on that line. And now this arc is fully constrained. What I don't want, though, is any of my future geometry caring about these two lines. So I hit escape to cancel this. And then I'm going to select this line and go over here back to my sketch palette and click the normal or construction option. Or you can hit the letter X. And what that does is it keeps all of my constraints that I created about this line. But when I go to do any future things like the loft that we're about to do, it's not going to care about these lines. All these lines are is reference geometry for these lines that actually matter. All right, so we're going to stop the sketch. And this gave us the profile of the sweep that we want to do. Now it gave us the path of the sweep. Now we want to create the profile. I want to tell it what I want that sweep to look like. So I'm going to create another sketch and click on this bottom plane. And then what I'm going to do is I'm going to model the shape of the tube right here. And the shape of the tube is a simple circle at 32 millimeters in diameter. So to create a circle, I'm going to go up to my sketch box here and click the circle option. And I'm going to rotate my sketch just a little bit so I can make sure that the circle is getting placed where I want it. And I want it to be at the very end of this line, but it's not letting me pick that line. And that's because the geometry isn't referenced anywhere in this sketch. So let's close out of the circle. And we're going to use this option called Project Old. And what it does is it takes old geometry from past sketches or extrudes, and it allows you to reference them in your current drawing. So I'll click that, and then I'm going to click the vertical line, and then you see that it makes a little purple node down here. And that means that that's geometry that I can now reference in this sketch. So we'll click that for the center point of my circle, tell it that I want it to be 32 millimeters in diameter. Click enter. And our circle is now created. So we can stop the sketch. And now we're going to actually create the solid geometry. So in this create menu, there's a lot of really cool things that you can do. We can extrude things, or we can revolve things, which is making a round object. We're going to talk about that in a little bit. But the option that we're going to use right now is called sweep. And what sweep does is it sweeps, what Fusion says it does, is it sweeps a sketch profile or a planar face along a selected path. It takes a shape and it runs it along a path, and then it creates a uniform shape. It's a really, really handy tool to do exactly what we're doing. So in the sweep dialog box, it asks for a profile. Profile is the circle. It asks for the path. We'll click the path. And then it creates it. As easy as that is. And the operation down here lets you do a whole bunch of different things. I think in this one we're going to just leave it as new body. I think that's the best way to do this. So now we have a body. And we have one half of the fork modeled. Now we could do all of that again, or we could have modeled the other side of the fork in the sketches. But the other way to do this, and frankly it's the smarter way to do this in my opinion, is we will mirror the geometry. And to mirror, we go into the create menu, click mirror, and what this will do is it will use a mirror plane, which is the center plane. This is the other reason I used the origin as the center of our model. And it allows us to mirror faces, bodies, features, or components. I've never actually mirrored faces before, but I mirror bodies, features, and components all of the time. And we'll do some of that in this. So right now we want to mirror bodies. And we'll say select this for the object. Select here for the center plane. And click OK. And real quick, I want to check. Here. Oh, it was these. Okay. I was remembering last night that I had done it as a new body creation at some point, and I couldn't remember where. Okay. So the next thing we need to do is model the center portion of the fork right here. But I want to give the live chat a second to catch up and ask if there's any questions with lofting or any of the sketches I did. And take a second to take a drink. Okay. So this is the first place where we need to create a new plane. And the way I'm going to do that is I need to look at how far away from the little scratch that I know is 200 millimeters to this is for our plane creation. So I'll check that real quick. It's about 70 millimeters. So what we'll do for that is we'll create an offset plane. And an offset plane says offset from some geometry or plane. I'm going to create a new plane. So I'm going to slide this up 270 millimeters. Click OK. And I'm going to create a new sketch. So we'll create a new sketch. We're going to use this plane as our reference for the new sketch. Again, working from our coordinate system center point here, I am going to make a circle, center point circle, and I'm pretty sure, but always check, measure twice, cut once, measure 3 times, model 5, probably, the way it usually goes. Again, this is 32 millimeter pipe. So I'll click enter. And measure how long it is. It's about 43 millimeters, which seems like an awful random number, but okay. And this time, we're going to extrude it. So we'll say stop sketch and extrude. And we'll click on the profile that we want to extrude. We'll pull it through, make it 43 millimeters. And the first thing you should take a second to notice is how the extrude defaulted in operation. It said, hey, we're cutting some existing geometry in half or intersecting some, so this must be a cut operation. And a lot of times that's exactly what it would be. But this time we are doing a join. And what a join does is it just says this geometry is intersecting with this other geometry and they're both the same body. So we'll click OK. And then the next thing that we need to model is the steer tube. So the steer tube is 25.4 millimeters. Does anyone know what 25.4 millimeters is? It's an inch, because nobody can actually respond in real time. Because this is a threaded steer tube, for those of you that like bikes, it says garbage China bike, so of course it's a threaded steer tube. And it is 157 millimeters long. Again, seems like an awful random number, but I'm going to take it. So this time, I'm going to create the sketch on the face of existing geometry instead of creating it on a plane. And that's totally acceptable. You do it all the time. And it's really handy when you're creating square things, because then you always have a planar geometry to start a sketch on. So we'll dimension this as 25.4. Enter to finish out the command. And then again, we can hit extrude, or the other command that works for this, that works really great, and it's probably one of my favorite Fusion commands, is press pull. And press pull does a lot of really neat things. It will extrude, it will fillet, and it will move existing geometry in ways that other CAD systems just tend to roll over and die and tell you, no, you can't do that. Why would you be able to do that? Fusion can, and it's one of my favorite things about it. So I'm going to click press pull. I'm going to click my geometry, and I'm going to say 157 millimeters. All right. This is pretty great. Oh, one thing that I did want to show you guys that's very handy. One, how to go back into a sketch and edit it. There's two ways. You can drop down the sketch menu, right click on the sketch here and say edit sketch. Or in the timeline, right click on the sketch that you want to use. Right click on the sketch that you want to use. If it ever comes up grayed out like it did, it's because you had it selected and then did it. Just click anywhere, deselect everything, and then right click on it again. I don't know why it does that. One thing that we can do is, if we were flip-flopping on units, but I'm currently working in millimeters, which is in my model tree here, I could say this is 1 inch or inch and hit enter, and then it will convert the units. And that's super handy when you're working in metric, which is my preferred unit system to work in for most things, but you're using like standard hardware like quarter 20 bolts or something like that. Makes it handy. Stop sketch. Get back in here. All right, so now this fork is made out of pipe. It's not made out of solid metal, and it doesn't actually matter, but I want this model to look like it's made out of pipe. So we could have done a couple things. We could have made our loft down here with multiple profiles and made it a lot more complicated. But the other thing that we can do is we can say modify and shell. And the shell command takes a solid geometry and removes material from the interior. I can't say it better myself, so I'll just read the description. Removes material from the part interior, creating a hollow cavity with walls of a specified thickness. It's super handy for things like this. So we just need to click on some faces. Now I'm going to select multiple faces, and to do that I'm going to hold down the control key and select all of the faces that I want to be shelled. And I'm going to make this tube 2mm wall thickness. So the inside thickness is 2mm. This is misleading. This should say wall thickness. Any Fusion developers are watching this. And now, look, it's pipe. You can even get the pipe bevel in this, which I think is pretty cool. Alright, it's looking more and more like a fork all the time. Okay, so the next thing that we need to do is we need to create the dropouts. Now, you notice a couple things about the dropouts. One, the dropouts aren't anywhere near the part origin. They kind of, but not really. The other thing, they're not anywhere near, get this in line with the camera, they're not anywhere near the center line of the tube. So how are we going to do this? Well, construction geometry to the rescue. First thing we need to do, we need to find the center line of our tube. So in the construct menu up here, we'll say axis through a cylinder, cone, or torus. Click this and click the tube for the right side of the fork, because this is the side that we were working with before. It doesn't actually matter. I just like to consistently work off the originating geometry. Then the next thing we'll do is we'll say plane at an angle. And what this does is it uses an edge of a rectangle or an axis or a line as reference geometry for creating the plane. And then it allows you to rotate the plane about that axis. So we have a plane here. And as we rotate around, I'm going to click on the front view here on my geometry box guy. If you guys rotate, you can click on the geometry box to rotate. This seems really inefficient to me, but I know some people that really like it. The other way is to hold down Shift and the middle button. Or if you're like me, I have my middle button set up to rotate and Shift and middle button set up to pan. We'll rotate it so we're looking at it from the front. And then I'm going to rotate the model about that center axis 90 degrees. Or negative 90 degrees. Doesn't matter. And then the next thing I'm going to do is take my calipers and eyeball how far the front face of that fork dropout is from the center of the tube, and it looks like it's about 8mm. And in my opinion, about 8mm is good enough. So I'm going to create an offset plane and click on the plane we just created and make a plane offset from that 8mm. And then I'm going to go I'm glad that you like the box. Other people in that list like the box too. It's fine to box. So I'm going to go into the model tree, and I want to keep some of my construction on. So I'll click down on it, and I want to turn off plane 2, because that's the center plane that we made, and leave plane 1 in. And then I'm going to turn off the origin because it's distracting me right now. And then we will create a new sketch off of this plane. And these dropouts are kind of oddly shaped, but they do have some critical geometry. The center line of this hole from the end of the fork is critical, both from the axis here in the center line, in the, we'll call this Y, because that's how it is on the screen, and the X. Those are both critical. The The rest of this shape is only matters for cosmetic purposes and maybe clearance if you really want to get technical about it. So I'm going to fudge this outer geometry using some sketch and some fillets, but I am going to make sure this slot is reasonably in the right place. And again, I'm going to use it with calipers. Eyeballing things off the center lines of poorly made tubes. Please, internet engineering community, don't kill me. So it looks like the center line in this axis is about 35 millimeters. And from the base of the fork to the center of the circle is about 10 millimeters. That's reasonable. I'm enjoying the live commentary. It's actually fun. People are actually doing it this time. So the slots are 10 millimeters wide, and that's pretty standard for 8 millimeter axles to give them a decent amount of clearance. So I use a center point circle to draw a circle in the air, and then I will use the D key to do some reference dimensioning. But again, it's not letting me select this because I forgot to project it. So we'll say project old, and I want to project this axis too. So I'm projecting the end of the fork and the axis to do some dimensioning from. So I'm going to create a dimension from here to here. Boy, I eyeballed that good. Round that back out to 35. This one won't be near as good. And then make that 10. Okay. Now the next thing is I need to go from the back of the dropout flange to the front of the face of the fork, and it is 40 millimeters, and the face of the fork to the bottom of the dropout flange is about 29 millimeters. And to rough that geometry in, I'm going to use a rectangle, a 2-point rectangle. And it is about 60 millimeters tall. Then I'm going to use the D key to do a dimension from the back of the rectangle to the base of the fork. That was 40. And the back of the fork to this front line was 29. Okay. So now we have some rough geometry in, but it doesn't really look like this. It's not cosmetically pleasing, and we don't have the slot in here. So to create the slot, because that's the main thing that we're worried about in this, I'm going to use the line command by using the L key. And as I'm creating this, I want it to be at the quadrant of the circle. So I'm going to hover over the center line, or the center point of the circle, and then drag up, and you notice it makes that dotted line and then an X on the circle. It's because it highlighted, or it constrained itself to the quadrant. And it'll go over to the base there. And then create the line on the bottom. Fusion's actually pretty smart about creating these constraints. And it makes things like this very handy. But I need to cut out the front of this circle and this line here. And to do that, I'm going to use the trim command. And the trim command's cool. They just added some neat features to it that I'm excited about. But what it does is it will delete all of the portions of the line until it comes up to an intersection. So here it will delete this portion of the circle until it comes up to here. And I can just click on these line sections. The other thing that you can do is you can click and drag, and it will cut the lines. And that was one of the things that I loved about Creo, and I hated that Fusion didn't do. And I don't know when they added it, but thank you, Fusion developers, because I was super excited when I figured it out the other day. Okay, so the next thing that we need to do is create this fun arc, diagonal line arc thing, and then these. So I'm going to use some basic geometry stuff to do that. First thing I'm going to do is create a center point circle, and we're just going to go all the way up until it's tangent with the outside here. And then I'm going to create a line by clicking the line, clicking on the circle, and coming down here and clicking somewhere that seems reasonable. This is all cosmetic, so I don't really care. But one thing that I do care about is this line isn't tangent to this circle. So to fix that, I'm going to go over here to my sketch palette, click the tangent constraint, click the line, click the circle, makes it tangent. But it did move my line point here. I'm just going to drag it down. And notice how the line follows the circle because it's constrained. That makes things super nice. And then I'm just going to give this line a dimension because it makes me feel better. And click the T key to turn the trim command back on and start getting rid of these extra line sections that I don't need. And Fusion's over here giving me a bunch of warnings about how I'm killing constraints. Sometimes that matters. In this portion, I don't care. And the last thing, I need to make a diagonal line from the bottom of the dropout here. And again, it's not a critical thing, so I'm just going to eyeball it. Hit escape. And trim it. Okay. So this stuff looks pretty rough, but it's exactly what I want because we're going to fillet it using a different command. So we'll stop the sketch, rotate it so we can see it, click on the profile and say press pull. And these are 4mm thick dropouts. And I want to create a new body in this. This is important because I'm going to mirror this geometry over to the other side of the fork. So I want to be able to do that without carrying the whole fork over with me. So we'll say new body. Click OK. So now we have this new fork plate thing in here. But it looks pretty rough, and I don't really like how it looks. I want to round things out because this is CAD, and we can. So I'm going to click press pull, and we'll click this line here, and I can just push this fillet in until it looks somewhat like this radius here. And 13.5mm seems reasonable. Click this one. That looks nice. Click this one. That looks real nice. And I could do all these as one, but they would have to all have the same radius fillet, like this. And I use the control key to add or remove more edges from the command. So we'll click OK. And that looks pretty good for the dropout. And the last thing we're going to do for this, I'm speeding up because I'm repeating commands, is I'm going to pattern the body, or mirror the bodies again. We'll click this. Select our center plane as our mirror plane. Click OK. And then we have our dropouts. And the last thing that we're going to do, because I want this to be all one body for later when I go to assemble this, is I'm going to go to the modify command and click combine. Now combine does a lot of really cool things. It will let you subtract geometry from each other, or in this case I'm going to combine the bodies for the dropouts into this tube. So we'll say join, and the target body is the fork. The tool body is this, and we'll click OK. So it won't let you do two at a time. So again, target is the fork, the tool is the dropout. Click OK. And now if we go into the bodies folder, we still have all one body. All right. So that is, in all of that, we covered extrude, sweep, mirror, and shell. Now, the last thing that I wanted to cover in this is revolve. So in revolve, we create round parts about an axis. And for that, I'm going to save this. We will do a new design. Actually, you know what? We can do it in this. I'm going to right click on the model tree. I'm going to say new component. And we're going to create the wheel for our fork here. So let's say 20-inch wheel. And I'm going to create a center circle. And before I do that, I'm going to make an offset plane. So I'm going to go through this a little quick so we can get into the revolve command and not burn too much overtime. So I'll make it 20 millimeters outside our fork, and then make a centerline circle. And I'm just going to use the extrude command real quick to make an axle. So I'm going to project the dropout here, and I use the C key to start up the center point circle command. We'll make an 8 millimeter axle, and then I'm going to press Q while I'm in Sketch to drop straight out of Sketch into press pull, which is super handy. And I happen to remember from my drawing and measuring last night that my axles are 160 millimeters long. That's not centered at all. That's okay, whatever. But the next point is what matters. So I'm going to create an axis through here, and then a plane at an angle off that. And I'm going to leave it at 0 degrees. The only reason I use plane at an angle is it's the only way to reference a plane from an axis. So this is where I want my sketch to be. And I'm going to create a new sketch. And I want it to be, we're going to draw the rim. So really quick, I'm going to project the insides of the fork dropouts and do a line between them. So now I can grab that line's center point. And I'm going to create some construction geometry. And I think the outside of the rim was about 18 inches in diameter. It's a 20-inch wheel, and the outside of the wheel was 20 inches. The outside of the tire, we'll say 18 inches. So 9 inches in radius. That looks pretty good. And then I'm going to make a 2-point rectangle using the R key. Actually, we'll do a rectangle. There's some interesting geometry that we can create, but let's use a rectangle for our reference geometry. So I'll make it 40. 20 millimeters thick by 40 wide, and make this top point concentric or coincident, and make sure that it's centered about this construction line here. And real quick, while I'm thinking about it, I'm going to click on this line that we used and hit the X key to make it dotted and a construction line. Now, rims aren't rectangular, so I'm going to start the line command and give it an angle. And dimension the angle so that it's a whole number. 70 seems reasonable. And instead of drawing that line again, I'm going to use sketch and mirror to mirror that line. So I click the line as the object, and the mirror line I'm going to use is my construction line that I created a second ago. And trim this outside away. And then the other thing is, rims aren't solid. So let's use the offset command. So I used O to start it up, but it also is in the sketch menu as offset. And we'll click this guy here. We'll make it 1.5 millimeters offset. Use the trim command. Get rid of these lines. Oop, let's not do that yet. Control Z to off or undo it. And then I'm going to use the extend command. The extend command is the opposite of the trim command. To extend these lines to the end. So it extends lines to the next intersection instead of trims them at the intersection. We'll trim that. That is sort of ish like a bike wheel. There was a point in time where I was almost a wheel engineer for Trek. We won't tell them that's how I draw rim profiles. But now we have the profile of the wheel that I wanted to do. and I can revolve that profile. Click the revolve. Click the profile. And then tell it what axis I want to revolve it around. I'll use this construction axis that I created earlier. Tell it that we want to make a new body because we're already inside a new component. And that we want to make it 360 degrees. If we wanted to make it 180 degrees, we could totally do that. And it's only half the wheel. Yeah, whatever you want. I want a full wheel. So now we have our wheel with an axle and a fork, and we're almost to a front end of a bike. And we've covered everything that I want to cover. I'm going to give the video a second to catch up so that the live stream can give you guys a chance to ask questions, anything you want me to cover real quick. But we're actually right on time, which I'm pretty stoked about. I'm gonna check Slack and see if anybody messaged me on Slack. Nope. Good stuff. While I'm waiting for questions, I want to plug two things. One, rivercitylabs.org. We are a really awesome group of makers and engineers and artists and just generally awesome people that like to create things and like to share ideas and all of that stuff. We're a non-for-profit makerspace, and we've recently started offering a digital membership that allows access to our Slack, now that I mentioned our Slack, which has about 60 people in it and is just insanely active. Last year, I cleared 20,000 messages myself, to give you guys an idea of how active it is. But it's full of people like me that like to share ideas and skills and cool things like this. The other thing I want to plug is Midwest Maker Fest. If you're anywhere near the Midwest, August 12th is our Maker Fest that we have here in Peoria. Last year we had about 5,000 people come to it. This year we have the biggest BattleBots competition in the Midwest. And we're going to have yard-sized board games, so yard-sized battleship with rockets that we're going to shoot over things, and yard-sized Settlers of Catan. Hopefully we're going to have drift trikes. It's not looking awesome, but maybe. And a couple other really cool things. So if you guys are interested in that and you're not part of River City Labs, maybe you should check out rivercitylabs.org. You can find our Facebook page at RCL Peoria on Facebook, and we're on Instagram and all of that stuff. So, all right, I'm not getting any messages on live chat, so well, I am. Lots of thanks. You guys are welcome, but no questions. So I'm gonna kill the stream because my chameleon is eyeing me like he's really hungry, and I'm kind of out of wind. So thanks, guys. I hope this worked out well for you guys. Fred says next time show us how to do the hub and the assembly can be animated. Totally. The assembly for the hub animated would be kind of boring, but maybe we can do the steer tube and handlebars and we can make them rotate. That would be cool. That would be a good way to do it. All right, 2 weeks. Let's do that. Thanks, guys. I'm out.